I am very excited to introduce our three presenters. Rob Klein, Architectural Manager of the NYC metro area for Rockwool. Todd Kimmel, U.S. Senior Manager of Sustainable Solutions. And Manaz Nikbat, Regional Specifications Manager, Ottawa, Quebec, and Atlantic provinces. So with that, I'll hand it off to Manaz. Thank you.
Hi. Thank you. Thank you, everyone. Thank you actually also to the Passive House Accelerator, all of you people that are pushing for Passive House. I just want to introduce a few people who are certified Passive House designers. You might have already heard of Alejandra Nieto, our sustainability manager. She presented on the Passive House Accelerator previously. Robert Blunt usually is there. He couldn't come today. He recently got certified. And myself, I'm also certified. And I'm also involved in Passive House since many years. I think I did my first Passive House airtightness presentation in 2003 or something. I currently chair Bâtiment Passif Québec, the Quebec Passive House Association. Rockwool also has certified Passive House details. And yeah, no, go ahead. It's correct. We at Rockwool actually value the importance of building partnerships with industry and associations, non-for-profit organizations, groups of people that are pushing the needle when it comes to improving the energy efficiency and carbon intensity of buildings. So we have some connections, sponsorships, involvements with all of these different associations. But we have a lot to talk about. I'm just here to do a little bit of an intro because we have let's say, experts on the topic here. Todd Kimmel, also certified Passive House designer. He's also not only member, but actually a co-founder and chairperson of RAINA, the Rain Screen Association in North America, involved in New York Passive House as a board member and in the Building Energy Exchange. And then there's Rob, so Rob Klein, who came to us with this really great background as a spec manager for a major EIFS manufacturer. He's also a member of EMA, so the EIFS Industry Members Association, and he's going to share his great knowledge with us.
Excellent. Thank you so much, Manaz, Zach, and all involved. So excited to have you all here today. I come from Eastern PA. It's a rainy, nasty day outside, but we'll make it work. So just a couple quick things, little overview of Rockwool in North America. We have multiple plants throughout the North American area, and we also have numerous other sister companies, our technical insulation, as well as Grodan, which makes growing medium using the same fibers we use for our building insulation, as well as Rockfon, which takes those same fibers and makes ceiling tiles. We do have some exciting news. We have another factory coming online, hopefully the first quarter of 2028. And just like our Grand Forks, British Columbia plant, we'll be using the electric melting technology as well as pulling hydroelectric power to manufacture the materials there. So we're very excited about being able to support a lot of the initiatives that are the West Coast is looking for us to supply. So let's start with understanding with EIFS, with mineral wool systems. In general, we are looking at continuous insulation on the exterior of our buildings for, as we're all very much aware of, thermal bridging. EIFS, even foam EIFS, is one of the best continuous insulation cladding systems that you can put on your building, primarily because the minimal amount of fasteners that might be needed for stone wool insulation applications, or even with foam EIFS, absolutely no fasteners whatsoever. So very good continuous insulation system, and hopefully growing in the market in the coming years, especially with sustainability and circularity and fire resistance that stone wool EIFS can provide. So we're seeing that growth, hopefully growing probably about 1.5%, which isn't bad, but we're looking for it to grow even more. Primarily, we're seeing applications in lodging, hotels, a lot of commercial applications like multifamily buildings. We're hoping the residential and applications increase, and hopefully that's why we're here today. We can see them more on passive houses, whether it's residential and single-family homes, or even large retrofits or new construction. I'm based in the New York City area as far as my region, and we see a lot of the buildings where EIFS is being used is on the side walls or the back walls or a shear wall or a penthouse. But we're also seeing a lot of applications commercial-wise that are looking to meet that passive house standard that are really embracing EIFS as a option. So EIFS with drainage can be used on all types of construction, single-story residential to multi-story buildings. It can be commercial residential, can be for renovations or retrofits or new construction. Primarily installed in place, but in the northern climates, we're seeing an uptick in panelization of EIFS. So year-round applications can be done with panelization, so something to consider in those northern climates. So in general, EIFS is a water-shedding exterior surface with a lamina that's applied over top of an insulation product, whether it be mineral wool or foam, and a drainage plane that's created behind that insulation board. For the sake of time and have a lot of questions, I've consolidated this slide into why using stone wool, which is kind of where we were going with these slides. But primarily using stone wool or mineral wool is for fire performance. We have very good performance that way. Operating temperatures we'll see for stone wool is around 1200 degrees, but we're not going to melt till about 2000 degrees. We have very good vapor permeability, and how that translates to EIFS is drying potential. So moisture that may be present in that system, whether condensation or due to damage, will have the ability to dry. Our foam EIFS brethren needs to rely primarily on drainage for that. So a good application and benefit of utilizing stone wool in EIFS applications. Stone holders are required to use their liquid WRBs in that system to provide it to be airtight. So no other manufacturer's products should be used. Warranty considerations would be at risk if they were not used. Stone wool is very stable as far as the R value and thermal performance. We are mold and mildew resistance. We will not promote the growth of mold and mildew, and termites absolutely hate us. We perform even better than termite treated wood. A benefit of that may be in the southern states or where termites are, you can terminate stone wool EIFS much closer to grade, whereas our foam EIFS brethren in termite-rich environments, you may see it terminating around 6 inches above. We are very UV stable. Our dimensional stability is superior. We will not expand and contract, which can cause problems with the lamina of the EIFS. And we're going to talk a couple slides here about operating temperature as well as acoustic performance. And Todd's going to talk a little bit more about sustainability in stone wool EIFS.
Awesome. Thanks, Rob. And thanks everyone for having us. As you'll see, I'm getting tapped in here on this presentation for sustainability stuff, and we'll get through some passive house case studies that used EIFS in a little bit. Before jumping into sustainability, just to provide some clarity, I know, Rob, you mentioned WRBs need to kind of rely on the system holders, as far as the applications. And just so everyone's aware, and it'll be apparent as we go through the presentation, is that, Rockwool does not manufacture a full EIFS system. We provide insulation to be inserted into the systems that are provided by other system holders. So that could be Stowe, that could be Drive It Tremco, that could be Parex. We are an ingredient as part of their systems, and we are part of their system. So it will be apparent as we go. I just wanted to kind of provide a little bit of that clarity in case there was any confusion on that. But yeah, with a focus on sustainability, I think it's important, the Passive House community is obviously very focused on reducing operational energy use, operational carbon. But we all have in mind, GWP also can come from the products and the production of the materials, and embodied carbon is really critical. And so that's really very apparent for us as well at Rockwool. So just in terms of the disclosure, particularly around products that are used in EIFS, XPS, EPS, and now Stonewool, this just gives you a little bit of a look at the GWP impact from these various products. So this is a chart that kind of showcases that. You'll see rigid stone wool is a little bit higher than EPS. And we're going to talk a little bit here in the next couple of slides about just the 360 degrees of sustainability, maybe beyond GWP and the things that we want to consider about products. But when you're looking at EPDs and you're looking at kind of comparisons, particularly with XPS, we want to make sure we're looking at the full life cycle of the product and kind of where those carbon emissions can come from, because there are certain things, obviously, in the in situ phase for some of the foam plastics where blowing agents and emissions during that lifespan are oftentimes not looked at effectively, but that is part of the picture. But of course, there's a lot of things that we want to look at, and I'll let Rob, you kind of push to the next slide here. I mean, we've noted EPDs and HPDs, and we'll talk a little bit more about that. When we look specifically at stone wools or mineral wools in general, and compare and contrast light density bats to medium density kind of semi-rigid products to high density boards, which is where our EIFS product will lie. Just be aware, when you're comparing and contrasting products, that density matters, application matters, understanding what type of mineral wool you're using, because you might be comparing a low density versus a high density. And those GWPs will differ. When you look at EPDs, there's also industry-wide EPDs, which you can see here by the light gray bars for these various products. But you also want to look at product-specific EPDs that manufacturers are hopefully producing directly that are more honed in on their specific products. So in this case, the red bars represent Rockwool. And you can see here, even though we are a pure stone wool, without as much recycled content as some of the slag wools out there, that even though we have lower recycled content, our GWP is quite a bit lower than our competition in the segment. Yeah, and so, I won't belabor this either, but again, sustainability is a dynamic equation. There's a lot of variables in there that are really important to think about, and Rockwool likes to kind of emphasize all of them. And first and foremost, and what's present on everyone's mind is fire resiliency, which has a direct relationship with sustainability, particularly for our friends in California. And so when we look at products, understanding the importance of non-combustibility and fire hardening is, I'd say, top priority and should be top priority in these conversations. But we do want to think about material composition, what's in these materials, are there off-gassing, are there any sort of chemicals that we need to be concerned about? Carbon emissions is obviously a big thing. How are we contributing to occupant comfort and health and well-being in terms of, again, maybe off-gassing or limits of off-gassing? Circularity considerations are really big, and they should be. So in terms of recyclability and the potential to take product back is a big thing, and that should be considered with materials, particularly with stone wool, where you have that capacity. Stable R values, R values that don't diminish at lower temperatures, R values that will remain for the life of the building and thus perform for the life of the building is really critical, because we want to make sure that what we're designing for in our passive house buildings or all of our buildings, that you're actually getting the payback over the life of the building. Vapor permeance, Rob mentioned that in terms of breathability, which becomes really important in passive house buildings, as we know, when we're making airtight, thermally effective buildings, or let's say doing retrofits, we're changing the hygrothermal kind of dynamics of the building. And so being able to allow breathing and drying capacity of the walls is really important, which you don't get with a lot of the foam plastics. And so stone wool is a really great benefit there. And so when we talk about embodied carbon, again, we want to think about not just looking at total embodied carbon of a specific material, right? Taking a material, understanding its carbon impact during production and multiplying it times, let's say, the square footage or the tonnage. We want to think about net embodied carbon. And so that's where there's a real benefit of, the operational carbon savings that you can get from insulation, but particularly insulations that can last the life of the building. And so when we look at the net embodied carbon, that's from our perspective, a little bit more of a relevant kind of identifier of the value around the total carbon discussion. But I'm going to turn it back to Rob now to let him get into the nuts and bolts of EIFS.
Thank you very much, Todd. So as I mentioned, acoustic performance is a big bonus when utilizing stone wool EIFS. Typical foam EIFS applications do not provide any acoustical performance unless a fiberglass or mineral wool bat is being used within that wall system. So we did some extensive testing on the mineral wool EIFS using both bat insulation and without bat insulation, different types of sheathings, different types of gauge and thicknesses of the studs, and also different thicknesses of the continuous insulation. Now, these were minimum numbers, so increasing the thickness of the stone wool might have a small amount of an increase in those STC ratings. But you see the lowest one with assembly 4 was at 45, which acoustic-wise is a great rating for your interior or exterior walls and provides great comfort to those inside. We also did testing for wood frames construction as well, with similar options with and without cavity insulation and different thicknesses and stud sizes. Additionally, one of the benefits of utilizing stone wool insulation with EIFS is with the trend to, in many cases, use a darker color for the exterior of your wall. Designers have used black coatings in the past and did not perform very well when it was a southern-facing wall in Las Vegas. The foam insulation literally buckled and it was just a horrible-looking product. So with stone wool, we're able to have an operating temperature much higher. EPS foam, typical for foam EIFS, is about 170 degrees, and we're around 1200 degrees. So it does open up designers to allow for darker colors to be used on the exteriors of the buildings. And another benefit too is that operating temperature comes into play when reflective heat might be affecting reflection might be affecting the foam EIFS application, which we can see on the pictures on the left here. So again, stone wool will not have the warping and disfiguration that might occur due to this reflective heat. So let's take a look at some of the differences in the installation of stone wool EIFS, but let's review the system overall. We have our backup wall structure utilizing a cavity insulation on the interior side of your wall. Only improves your acoustics and fire performance, but the liquid WRB, and again, that comes from the system holder or the manufacturers of the EIFS system, is installed on that either sheathing, masonry, or even CLT structure. Then a joint sealant is also mentioned here. Again, this comes from that manufacturer and as required depending on the type of substrate. The adhesive that's used is applied to the back of the insulation board and is applied in vertical ribs of adhesive with a notched trowel. Then the insulation is installed on that wall. Once that dries, then mechanical fasteners are then installed on that system. And that's one of the main differences between our typical foam EIFS and stone wool EIFS. A base coat and mesh application is then installed over top of the insulation. This is a wet on wet on wet application. The base coat material is installed. The mesh is then embedded within that, and then more base coat installed over top to give it a uniform look all across the board. So this helps tie in the boards, also provides some thickness for the application to help smooth that surface. And then finally, the finish coat's installed over top. Here's a picture of the application of the adhesive to the back of the board. And just to note, the adhesive as well as the base coat are the same material. So base coat adhesive is the typical name for that from the manufacturers. The manufacturer, the system holder, provides guidance as to the spacing and the depth of those ribbons of adhesive, typically a 1/2 inch to 3/4 of an inch, depending on the manufacturer. Dimensional stability and dimensional tolerances are very important in the EIFS industry, making sure we have those 2-foot by 4-foot boards. We also have a specialized machine that does quality control for our EIFS boards. And that EIFS board is called Front Rock from Rockwool. And they do a UV light check on those boards, because this is really the only board that Rockwool manufactures that has something being applied directly to it. So if you can imagine taking a material and putting it on, and our manufacturing of our material, we're literally taking lava, making fibers out of it. So we may have what they call shot or cinders that might be there. So that's a layer of quality control that we have within our factory, and that's only in our Mississippi location. We are able to manufacture a monodensity and a dual density board. There's some benefits to both, and we'll talk a little bit more about where and why they might be used. Most of the system holders for stone wool EIFS list the maximum thickness as 4 inches. However, some may entertain applications up to 6 inches on a per job basis. Our R value per inch with the Rockwool Front Rock board is an R4, regardless whether it's the dual or mono density type. We are able to cut reveals or bands within the stone wool insulation on the exterior. These are done prior to the application of the base coat and mesh. There are specific requirements from the system holders or manufacturers with regard to the remaining depth after the cut is done to the back of the board. Typically, it's around 1 to 1.5 inches. These reveals, as I mentioned, are installed prior to the base coat and mesh, and also a consideration when we're looking at the placement of those aesthetic reveals is where expansion joints might be placed, and also preparation as to where fasteners may be placed. So having fasteners placed, obviously, where a reveal might go, might be, not good, not advantageous to do that. So here's a picture of an EIFS application in New York City. So you can see the reveals at the bottom of the window frames and the top, or however you might see that being oriented. Reveals have two purposes. In this case, it might be at the floor line of providing some expansion, but also gives the applicator a start and stop. So imagine if this building was designed and they wanted aesthetic reveals, and it might be only a couple inches above that floor line reveal. Aesthetically, that wouldn't be work, and we'd have to revisit the application. So a consideration when we're looking at it both on commercial but also residential buildings as well. An important part of the EIFS application is back wrapping. We need to have the base coat material be left exposed and not finished be installed when we're terminating either for an expansion joint or at a window frame. We need to be able to put sealant, whether it's stone wool EIFS or foam EIFS. That insulation needs to be coated with the base coat so that sealant can be installed against it. Also on the right-hand side here, we'll see what we call a starter board. So the mesh is being installed prior and allowing it to dry. And what that is, in this case, it's that starter board is either used over a window or at grade. But when we install those ribbons of adhesive on the back side of this, now we have a very clear drainage pathway. If we were to install this back wrapping and still have it wet and then put the adhesive on, we'd have a very messy drainage, and drainage might be compromised. So as I mentioned, a key difference in stone wool eaves compared to foam eaves is mechanical fasteners. We do need to have those mechanical fasteners in place because the tensile strength and the fiber orientation of our insulation is such that wind, that negative wind load could have the possibility of pulling the fibers apart. So holding that in place is critical. We're still getting the drainage from the ribbons of adhesive on the back. So different types of fasteners that we're seeing in the market is either a countersunk or a flush-mounted fastener. As you can see, on the left-hand side with the countersinking, we're putting that fastener below the surface of the insulation face. And the tool pictured here on the bottom right is the tool that's used to remove the insulation as it's in place. And then a provided plug is then put over top of that. And that really helps minimize thermal bridging of that fastener. Also helps reduce the potential for telegraphing. Now, in this situation with the countersinking, we're looking at utilizing the monodensity product because that outer layer, that dual density, that higher density outer layer is right about the level of that depth of countersinking. So with the flush mounting, we can utilize both the monodensity and the dual density product. One of the benefits of the dual density product is it's a lighter weight at a higher thickness. So that outer density part stays the same regardless of the thickness of the board. Because we need to put additional base coat and mesh, typically because we are not able to sand the sand or outer layer of the front rock board, and we tend to put more base coat and mesh on. And we're seeing that not having or helping to reduce the telegraphing when we do flush mount installs. So depending on the manufacturer or system holder, they provide configurations for the number of fasteners that are being used. Some manufacturers have say 9. I want 9. That's all I'm going to recommend. Others may have 6 or even 5 fasteners per board. And really, what it comes down to is the building type, the wind load resistance that would be required for that project. So a 2 or 3 story building, you might get away with 6 fasteners, a 60-story shear wall in Manhattan. We're definitely looking at 9 fasteners per board. Even sequencing comes into play sometimes as well. There's one manufacturer that will put 4 fasteners in the board prior to the base coat and mesh, which is the typical application, and then come back with 5 fasteners after the base coat and mesh. Actually helps a good bit with wind load resistance. So as I mentioned, we can't rasp or sand that outer layer. So we spot prime all the fastener heads or plugs, and then come back with additional layers of base coat and mesh as necessary to get a smooth surface. Again, aesthetic reveals come into play with this and helps the applicator with getting an appropriate levelness of the application. A big concern with many specifiers is impact resistance with EIFS. I'm not going to go too deep into this, but there are numerous resistance levels, standard all the way through ultra high. Stone wools and front rock EIFS board is able to give. And so that impact resistance is actually better when we're utilizing stone wool insulation. One of the things that really plays a part in the ability for the higher impact is looking at differences in weight of the mesh. So on this side, this one's a 20-ounce mesh, and this is the typical 4.5-ounce mesh. So the heavier the mesh, it's almost like having more rebar within your concrete. So we perform actually quite well with that. To give you an idea, and I know Todd's going to laugh at this, but to give you an idea of what does this mean? What does standard impact resistance mean? How can I quantify that? So I'm going to hurt my knuckles here, but I can hit that pretty hard, and I've been hitting it for days now. And that's with just the standard mesh. So the ultra high impact mesh is, you can hit that with a sledgehammer with really no repercussions unless you get up to about 5 or 6 times. So the addition of complex architectural features that typically are foam are allowed by system holders. They need to be base coated and meshed prior to the application, and they are adhered to the existing base coated mesh of the Stonewall EIFS system. As you can see, they have to be on that layer. They cannot go back to the substrate. So yes, we can cut them for aesthetic, can cut front rock for aesthetic grooves and reveals, but we just can't get these complex shapes and features. So Modern EIFS has a wide variety of finishes. We're able to mimic a lot of different looks. And we're final picture here before we move on to a couple case studies. This is a panelized application of a hospital in Georgia. And on the right-hand side, you can see the panel. We've got various textured finishes, and then actually what they call template brick being installed over top. So a lot of options that are available for EIFS in just virtually every application. So, oh, sorry, we're not on case studies. We're going to talk a little bit more about code. Sorry about that. And coming from the EIFS industry, I'm always a proponent of how great this system is. Yes, there were some issues that we had in the 90s, but to be code compliant, the EIFS industry really went to bat and came forward with ASTM E2568, which houses more than 40 tests and standards that EIFS must meet to meet code. I challenge every one of you to find a system that has the amount of testing, and I say system, not assembly, system that has from a liquid WRB all the way out to the finish that's tested to the level that EIFS is. One of those tests is EIFS with drainage, ASTM 2273. And literally that opening up on the top there is water is put into that opening, and you have a certain amount of time for that liquid to escape the system at the bottom. And to pass ASTM 2273, you need to have 90% efficiency. What I find interesting is that this is a EIFS test. This is a test that EIFS must pass, but many of the manufacturers of WRBs, whether they be liquid, sheet goods, peel and stick goods, in many cases reference ASTM E2273 as them passing that drainage test. So they had to have used it in an EIFS system, which I find interesting. So as specifiers and owners, just be confident that this test is being used for drainage efficiencies, not just for EIFS, but across the entire spectrum. As far as lot line considerations, we will not take away from any ratings of those walls, and we can be utilized in those systems over top without changing the rating of that wall. An interesting thing coming up in the 2024 International Existing Building Code is that if the building does not have an automatic sprinkler system, the envelopes of that building shall not be or shall not use a combustible exterior wall material. The one exception of that is that single story and less than 15%, but also water resistive barriers that are deemed combustible. There is an exception if it's the only combustible component of that wall. So on everyone's minds is WUI zones and combustibility. So the WUI zones have very specific requirements and have a lot of different code considerations for them. I know that Stonewall, Rockwool's comfort board and our roofing board, Top Rock, are listed on the CAL FIRE materials list. So if your project is within a WUI zone in California, the non-combustible insulation needs to be utilized there. And that comfort board can be utilized in a lot of different applications, which we'll touch on briefly. So let's look at a couple case studies. Todd, I'll let you take it from here.
And thanks, Rob. Yeah, no, these are good studies. They're both passive house and thus relevant, obviously, to this audience. They're both retrofit, which is also, I think, a really unique kind of discussion here, and the ability to kind of implement and use stone wool EIFS on, a lot of these buildings that we need to reduce the carbon on that are existing. So, this was a project which you guys may have heard about. This is the Ken Sobel Tower in Hamilton, Ontario. This was completed a number of years ago now. ERA Architects was involved, and they were kind of given this challenge of working with a developer who initially wanted to tear this thing down. They came and salvaged it because they didn't want to lose, the embodied carbon within the structure itself, and they convinced all the stakeholders that they were going to make this building stick around and become a lot better, right? So it was struggling with a deteriorating envelope. It had no insulation. There was all sorts of hazardous materials and mold. There was really no thermal control going on, and most of the systems were at end of life. You can see some photos here of the balconies that were existing. They decided to just remove those balconies rather than navigate the thermal bridging as part of the retrofit. You can go to the next slide, Rob. And so the goal here was to create an ultra low energy retrofit that maintained the affordability. This was a affordable housing project. So they wanted to make sure that the monthly bills were quite low. And their approach to doing that and to reducing the greenhouse gas emissions 90% was to move towards Interfit standard. And so that's exactly what they did. This was developed shortly after the Grenfell Tower tragedy, which was also a retrofit. And so the impetus here, while the code didn't necessarily mandate it, was to move to a fully non-combustible solution. Also, given the fact that I don't believe there was any sprinklers in this building, it only made right sense. And so that's what led them to the decision in this case to use stone wool insulation. They had some other, requirements or goals in mind, including passive climate resilience to extreme weather conditions. We'll talk about that in a minute. And so we can go to the next slide. Just quickly, visuals. I know we've seen some visuals along the way. This was kind of what we're looking at with the mechanical fixings of the boards back to the wall and the start of the rendering finish of the board itself. In this case, they did use a 6-inch EIFS board here. So, quite a bit of insulation, roughly, what is that, R24 going up on that. So, yeah, you can go to the next slide. And so, I'm sure this has been discussed in the past, but the byproducts of passive house, and maybe it should be one of the focal points, is the passive survivability aspect of these buildings, and the fact that as we're going through climate change events and seeing power outages during extreme weather conditions, understanding the ability to shelter in place, particularly for populations such as senior housing or affordable housing that might not have the same ability to evacuate homes like many of us on this call, having a structure that can withstand the storms and hopefully, not provide risky conditions for the occupants until, efforts to get power back on is really important. So ERA did a study of this particular structure, and you can see the blue line represents the original design. The red line represents the proposed design under passive house conditions, and the black line at the bottom is the outdoor temperature. So the vertical black line is where we see a power outage, and you can see this is in Celsius because we're in Canada. But the blue line above, which represented again the original conditions, quickly drops below 15 degrees Celsius, which is the survivability threshold line. And so people in this building, within minutes or an hour of a power outage are at risk, of survival in that structure. Whereas the passive house line hovered above the 15-degree mark for 48 hours, which is a big deal in terms of, hopefully getting the power back on or finding a way to effectively evacuate that building. They did the same study for summertime blackouts, and it compared a half day of being able to stay in place with an original design to 4 days of being able to shelter in place with the passive house proposed design. So a big deal for these types of buildings. You can go to the next slide. Another retrofit, this one is close to us here in New York City for Rob and I. This was a Baxter Ingui, or Ingui Architects, I should say, project Engine 16. This was an old firehouse of all places in New York City. It was not being used as a firehouse anymore. It was moved to a multifamily. But this was a tough building because it was, they wanted to preserve it. It was a historic value. In New York City, we have a new building code that has been implemented as of November of 2022 that's put severe restrictions on the use of foam plastic, and really integrating fire blocking requirements in EIFS systems and other types of systems to address that. It was a high density neighborhood, zero lot line conditions, really a focus on fire safety was there, not to mention trying to meet the energy requirements under Local Law 97, which is going to start finding buildings that are exceeding the allowable carbon for that location. So you can go to the next slide. And so the goal here was, again, ultra low energy retrofit, moving to interfit standard, maintain the operational affordability for the tenants, addressing the fire resiliency within this multifamily building based on the spaces and the kind of, the condensed neighborhood that this was being constructed in. Moisture management, with any old building, as again, you're starting to add air tightness, you're adding insulation, it becomes all the more paramount to ensure that, what a building that used to dry out very easily from thermal transfer across the enclosure is now not going to dry out as easily when you add air tightness and lots of insulation. So what is the quality of that brick, and how do we make sure we can manage diffusion and drying capacity? And so that was a big part of this conversation and what led them to consider products like stone wool for their application. All right, we can go to the next slide. And so this was the solution, right? So they ended up in this case using a Drive-It Tremco system, with stone wool, with rock wool insulation. Again, it met the requirements of Local Law 126 and the fire requirements. It avoided the use of excess fire blocking, because if you don't have combustible materials, you don't need to fire block. And you also didn't need to worry about abiding to NFPA 285 compliance, again, when you have non-combustible materials. So it checked the box of fire resilience. It checked the box of resiliency in general for the safety of the building, and kind of gave it a nice finish that was well received by the occupants moving forward. So in this case, they used between 2 and 3 inches of semi-rigid stone wool. It went over CMU and block in certain cases on the backside of this building. Back to you, Rob.
Excellent. Thank you, Todd. So currently the front rock in the North America is available, as I mentioned, in the mono and dual density, with thicknesses up to 4 inch on the dual density and up to 5 inches on the mono density. We are, as I mentioned before, we're all seeing applications of up to even 6, but those are typically done, those are done by laminating 2 boards together to achieve those 6 inches. Passive house considerations with EIFS, generically the same as phone systems, except for the additions of fasteners. The drivers for stone wool, obviously, is continuous insulation on the exterior, but non-combustibility, sustainability, the owner or architect not wanting to use a foam product, and of course, code that we're seeing in many cities across the U.S. Just a reminder, system holders WRB is required per testing. Thicknesses typically around 4 inches, possibly up to 6. We're able to mimic a variety of finishes with EIFS. And then lastly, as an architectural rep and talking with specifiers, but conversations with owners and architects, we talk a lot about cost. We are a more expensive system regarding installation as well as actual board cost. But the appropriate specification, that conversation with that architect and that owner, setting those expectations, managing them, and eliminating the value engineering that might happen at the end, really kind of holding fast to saying this is what I want because of all the things that we've talked about today.
Yeah, and I'll
So
just add to
go
that,
ahead.
Rob. I mean, the growth in New York City has been a direct result of the fire code changes and really the limitations that we see on foam plastics as a result of that. The other opportunities that we've seen stone wool EIFS being used is where the developer, the owner, just they don't want foam plastic and they don't want to have a combustible exterior. And yes, it's going to cost them a little bit more, but that's the direction they're going. There's been times where they don't want the embodied carbon of the foam plastics, so you've got a sustainability driver. So it's really a code, sustainability, and non-combustibility driver. But if you're in a position where value engineering is at stake and you don't have somebody that's going to hold through on the mineral wool, it's going to be 30% more expensive most likely than what you would see with foam. So though that conversation should be transparent up front, with the stakeholders.
Excellent. So we do have some additional slides with regard to stucco applications, but I'd like to pause here and let's maybe address any questions that we might have from attendees.
Yeah, fantastic. Thanks, Rob, Todd, and Manaz. There are lots of questions here, so we're going to keep you guys busy. I think what I'm going to do is prioritize questions for people who are still on the call, which I think is pretty much everyone, and then we'll follow up with questions from folks who have had to leave. So therefore, there is a incentive for you guys to stick around and ask your own question. Let's start with Paul Heron.
Okay. Hi, I think Manaz had answered one of my questions, but I certainly welcome a greater explanation. And that was I noticed in the slides on page 21 in the assembly details, you had comfort board in between a steel framing, and then you had the rigid exterior insulation. And my question was really about why doesn't the steel framing in that assembly negate the insulative value of that insulation? Now, Manaz hit on that, but perhaps you can expand on that a little bit more.
Clearly, when we're using insulation in between steel studs, if there were no exterior insulation, we can look at an effective R value that is reduced by 40 to 60%. So we're really throwing a lot of, R value out of the window. But in this case, we're using a continuous insulation on the outside. So that's going to break that. That's going to act as a thermal bridge. It's going to interrupt that heat flow through the steel stud. So if we add an inch of insulation, we could probably bring that ratio down to maybe 30%, and so on. So the more exterior insulation you put, the less the influence of the steel stud. So you could obviously put everything on the outside, but if you add insulation on the inside, you can work on the thickness of your wall. So if you leave that space empty, you don't get anything for it. If you add insulation to it, you can improve your R value, your total R value for the wall. So, you can decide, am I going to put another inch or two outside, or am I going to put the 3.5 inches inside? And is that going to give me enough and basically give me an inch more of floor space, right?
Yeah. And I would just add to that, speaking as somebody that works in a lot of projects in New York where space is extremely expensive. I mean, the ideal thing, Paul, is to put all that insulation on the outside continuously, not just from a thermal efficiency perspective, but from a hygrothermal perspective and managing dew point outside your structure. But when you don't have the space or the money, or if you want to add R value into the stud, it's better if it's done if you have continuous insulation on the outside, because it reduces the impact of the framing thermal bridge. You're not going to get 100% of that R value, but you're going to get a lot more of it than if you had no exterior continuous insulation. And so in New York City, if you're doing metal stud framing, typically you're going to have a little bit of here, a little bit of there.
Understood.
But with that said, Rockwell also offers really great complementary building science services. So if you ever need to assess dew point or moisture in a combined system, you guys should reach out to us and we can study those projects to ensure you're not going to have those issues.
Thank you.
Great. Thanks, Paul. Next up is Ken Nohazar.
Hey, thank you, Zach.
Yeah,
So
thanks.
had a couple of questions. I think Rob addressed this a bit, but this was relative to the pull-off resistance. So with a foam EIFS system, we have continuous adhesion, so we're spreading out that pull-off load across the area. Here we're concentrating it on the fasteners. So can you talk a bit about how that limits the overall aggregate pull-off resistance of the system?
Correct. So we are certainly reduced. Again, coming from an EIFS manufacturer with foam, it's the wall actually buckles before the insulation is pulled off of that wall. So that you're exactly right. That is the strength of that product. So the limitations are there, and if you have a project where you need to make sure that that wind load data is collected and the system holder is involved with that decision making, because they do have the same wind load testing that's done for foam EIFS is done for the stone wool EIFS. And as I mentioned, the one system holder has 4 into the board and then 4 after the lamina is installed. So we're meeting wind load resistance requirements for 60-story, 50-story shear walls here in New York City.
Great, thank you.
Thanks, Ken. I should also mention that if you asked a question and it was answered in chat, we may not have you on the queue here. We're prioritizing questions that weren't answered. But if you have a follow-up to your question, please go ahead and put it into chat so that we can add you to the queue. Okay, so next up is Graham. How's it going, Graham?
It looks like he just had to sign
Oh,
in.
Graham just left. He was here just a moment ago. Okay, too bad. Next up is Maurice.
Hello, everybody. Thank you for the presentation. I wanted to understand a little bit more about the drainage plane that you were referencing. Is that like a rain screen air gap? And if so, is there a min and max dimension that's recommended? And maybe if you could talk about any effects on the R value from air movement behind the insulation. Thank you.
Correct. So, so it is an ongoing conversation with my colleague at RENA that's also on this call. So the right now the determination being a rain screen is still kind of up in the air. As I mentioned, the adhesive is installed half-inch, 5/8 of an inch thickness. And when it's pushed onto the wall, it does compress down, and you typically have about 1/8 of an inch left over. These systems and details for EIFS are typically sealed on both the bottom and the top, and there are some variations to that, but we're not seeing any convection occurring behind the insulation boards. So we don't have those concerns, and there's no concerns as far as R value, and basically because that convection is not occurring. Hopefully that answered.
It does. Thank you.
Great. Thanks, Maurice. Okay, we have Ian Broomfield next.
Hello, everybody. Just a quick question. I'd like to pass this along to my specifiers, but I was a little delayed joining, and I don't know if regional availability was discussed. So do you have availability on the West Coast?
Absolutely. Yes.
Yeah.
Yes.
Okay.
And just to, I don't want to belabor that. So, we are in allocation, but you should be able to access our product out there. It's just a matter of the timing, but it should be about a 6 to 8 week lead time expected. So just bear that in mind as you're planning your project schedule. But the distribution out there does have access to the product under those allocation requirements.
Okay, thank you. Appreciate it.
Yep.
Thanks, Ian. Next up is Jeff. Hey, Jeff. Jeff X.
Hey guys, how you doing?
Good. Hey,
All right,
Jeff.
so I had
Hello.
a couple of questions. We're building a house right now, and we're speccing the Comfort Board 80. So in conversations, and I think I talked with you, Todd, about this, Comfort Board versus Front Rock. If you're using mesh anyway, Comfort Board we feel is a little more handleable. Is there a difference quantifiably in using them? Is there a benefit to using the Front Rock?
I guess
So
I'll
go ahead.
let Rob.
Go ahead, Todd.
Well, I was
No,
just
no.
saying, it depends on what are you planning to use it, Jeff? I forget, as a stucco system or as an EIFS
Yeah, so
system?
we're using U-stucco on the exterior. So we're gonna mesh it anyway because we want that pull off. We talked about the Front Rock, supposedly being able to be, self-meshed or whatever you want to call it. We decided to go with the mesh anyway. But we're doing Comfort Board. I don't know if there's a cost difference, is there
Well,
a
so the
quantifiable reason to go with the Front Rock other than that?
No, I mean the Comfort Board 80 is the right product for the stucco applications. Front Rock would really only be sold through the partner distributors that are signed with the system holders. So Front Rock wouldn't really even be an accessible product unless, Jeff, you were using Stow or Drive It or
Okay, we're using the
RX.
U-stucco product, which is it's a European product based out of Turkey. It's not stucco. It's a synthetic product. It's more like an EIFS than it is anything else. But okay, you didn't mention anything about being restricted product, so that
Yeah.
answers that question. I'm just going to run through them real quick. I saw the pictures and I actually answered the question. The pictures in your slide set had the fasteners that were on the second layer of insulation holding the mesh down as well, which is what our plan was. It looks like it's an operable system.
Correct. Yeah. So that's the one system holder does have those that sequencing of fasteners. I will add one thing to your previous question. With the direct application of material to the Comfort Board product, just be aware that you might have some of that bleed through if there's any cinders or shot that might be on the surface of that board.
No, we're going to mesh it. We're going to mesh it.
No, I understand, but you're still applying product directly to the Comfort Board. As I mentioned before, the Front Rock does go through that additional testing as far as trying to eliminate that being on the surface of the board. So,
I see what you're saying. Okay, yeah, I get it. In the system I'm using, I don't think it's going to be a problem. Is there a specific fastener pattern for CMU construction? What we're doing is closest to CMU. It's AAC, but it's closest for CMU. Is there any different pattern for that?
Not that I'm familiar with. I know stucco applications require, there are some code requirements for that. We do have some requirements as far as the weight of the product that's going over top of, or that is being installed over top of Comfort Board. But being CMU, that's a little different. I don't know of any specific requirements for that.
Okay. And I think you answered the question about 4x8 sheets. We just think there's a value in less handling with that. And you said it's only available up to 5 inches right now. Or somebody said in chat that they're working on 6 inches.
So we're talking that conversation was specific to the Front Rock board.
Yeah.
Okay.
I don't know off the top of my head what the Comfort Board the thicknesses might be, but I do know you can get them in those larger dimensions. Front Rock is
4x8 up to 5 inches thick.
Yeah, but Front Rock is only 2x4. It's only
Right.
2x4.
I'll be honest with you, a 5x8 sheet 4 inches thick is pretty damn heavy. So
Yeah.
That's why we limit the size in.
Yeah, I was on a project for stucco, and they were doing those large sheets, and it was 3 inches, and it took 3 people to manage that.
Yeah. All right, thanks, guys. I ran through all the questions.
Thanks for the questions, Jeff. Great.
Appreciate it.
Thanks, Jeff. Okay, Michael Marsh, you're up next.
Hey, so we're in Southern California working on a couple fire rebuild projects, and we've traditionally used 3-coat stucco, and I've never specified EIFS systems before, but just broadly, since Comfort Board 80 can be used with 3-coat stucco, or this alternate product can be used with EIFS, what's the advantage, in your opinion, of pursuing EIFS as opposed to 3-coat?
So flexibility, there's a couple things along those lines. The ability of the building to move the structural rigidity for EIFS is L over 240. Stucco is L over 360. So the only concern that I would, not concern, the only consideration you might have is if the project is within the WUI zone or will become within that WUI zone, you would have to utilize a product that's CAL FIRE tested, which would be the comfort board. We're hoping in the coming near future that Front Rock would be included in that, but obviously it's a non-combustible system that way. Damage is one thing we talked a lot about. It's a compromise there. If you took a lacrosse ball or you know your lawnmower and it shoots a rock against the wall, if it hits stucco, you might see that spidering effect across a large area, and that whole area might need to be repaired. With EIFS, that rock would hit it, and basically the size of that hole is minimal and it's easy to cut out and repair that way. Some other things to consider is traditional looks. EIFS does use an acrylic finish. You can't use the cementitious finishes that we see on stucco claddings, and I'll show you one here. This is a Santa Barbara Mission finish that really can't be installed over top of typical EIFS applications because it is too flexible, and cementitious finishes are more rigid. So those are some of those compromises. The other thing is weight. Even with a stone wool EIFS system, we're looking at somewhere around 3 pounds to 4 pounds per square foot. Traditional EIFS is with foam is about 1.5 to 2. 3-coat stucco systems with stone wool EIFS are about 14 pounds per square foot.
Yeah. And do we need control joints like we would for three-coat stucco?
So EIFS does not require control joints. The aesthetic reveals many times get confused for those control joints.
Okay.
But yes, with stucco, you still have those control and expansion joint requirements for every 144 square feet.
Got it. Okay, thanks so much.
Thanks, Michael. Okay, Justin Taylor, you're up.
Hey, everybody. Thank you for the presentation. That was great. I mean, it's always... can you guys hear me?
Yep.
Yeah, we can hear you,
Good.
Justin. Good to see you.
How are you guys? You too. Fine. How are you doing? Yeah, so one of the questions, like comparing traditional foam EIFS with the mineral wool, is your ability to cut into it, and like with the foam, I mean, that you can cut into it and make kind of shapes. Like specifically, I'm thinking of windowsill condition where you might want to have a sloped sill. That it's already shaped into, like when to go to install it. Are you able to do that on site also with the mineral wool?
Yes. The product is actually, and I should have done it, but it is actually very simple and easy to cut. It cuts very well and clean. For those particular applications like a windowsill or even beveling, a lot of times you'll have a bevel for your sealant joint so it gets hidden back in. Those are very simple, easy to use. We see guys cutting it with a table saw. We see things with a jig that they create to have that angled cut. Once you get that in place and you can have that consistency, it's just setting that up. But the stone wool EIFS cuts very, very nice and straight along for those types of applications. It's just the intricate cornices and things like that that become difficult.
Awesome. Thank you.
Great. Thanks, Justin.
Thanks.
Ken, did you have another question? It looks like you may, and if you'd like to ask that.
And I think Bob hit it, and I was trying to write it down. It went a little quick. Relative to the weight of the system. So you mentioned you have 8.5 pounds a cubic foot density for the insulation. So probably about 3 pounds a square foot for 4-inch thickness. Can you tell us about remind us again about the weight of the base coat and the rest of the system so we can figure on the dead load?
Yeah, I unfortunately don't really have a great number for you on that. Yeah, I'd have to do a little bit of digging on that for you. But just keep in mind a foam EIFS application, when the lamina thickness is probably not going to exceed 3/8 of an inch, if even that, maybe a 1/4 inch. Maybe some of the coarser finishes might be a little thicker. So we're not talking about a lot of product being on the exterior of that. Excuse me for a second. So yeah, I can work something out for you on that.
Okay, thank you.
Awesome. Okay, Peter, you're next.
Hello, and great product and great discussion about it. You mentioned that the fastening points had either 6 or 9, depending on the need or the height of the building. Is there a Rockwool product that has pre-cut counterboard fastening points with either 6 or 9-point attachment holes? Is it done yet, or do you have to do it on site with the drill?
Yeah, it's done on site. Imagine trying to do that, and also consider where your aesthetic reveals, where your expansion joints might be. One thing that sometimes I forget and overlook is with the fastening pattern. Notice that it's not the edge of the board that's against the stud. We have it moved away. So yeah, so pre-cutting those holes would be rather different. Now, you could probably plan for it once you get it on site, but not before it's on site.
Would there be an opportunity for some portion of your product to have that as an adaptation? And it would save a lot of labor on site.
And I'm sorry, I just want to make sure. In other words, saying that these holes are pre-drilled or pre-cut?
At
Is
the
that what you're
factory,
mentioning?
yeah, if you have a process at the factory that you could have those in those places at regular intervals like they are presented here,
Yeah.
because the stud placement would also be in regular places. Yes, the join of the boards in between, but I like the way it's done.
Yeah, that's an interesting proposition. I'm pretty sure our production, that would have to be post-production. So certainly something that if the market bears it, we could certainly look at that.
Very good. Rockwool's been great for 30 years for me.
Excellent. Good to hear.
Thanks, Peter. So Simone and Anne both needed to leave, it looks like. So Francisca, you are up next. Putting you on the spot a little bit here. Jump in the queue.
Excuse me. I am just wondering whether there are any toxic materials in the EIFS or the glue for attaching the Rockwool.
So Todd, I'll let you talk about the board, but as far as the it's an acrylic liquid WRB that's used. So just same as any type of acrylic paint. And you'd have to check with those manufacturers to see what the specific, maybe an MSDS sheet or something, to look at that. The base coat material is highly polymer modified, again, an acrylic resin being or powder being added to that cement layer, so that really nothing concerns there. And then the acrylic finish, again, it is a high performance acrylic product, and the aggregate that creates the texture, whether it's very or very rough, is actually marble. So now, as far as that's concerned, those products are there. But Todd, if you want to talk a little bit about the front rock and I guess Rockwool in general, as far as materials that way.
Yeah, I mean, we do offer HPDs, and the products in our portfolio are all Red List approved. We do have Red List free products, but the front rock would not be on the Red List free. So there is some trace of formaldehyde in the binder. That's not at a risk level, obviously, for the the people operating or living with with the products, and they do meet Green Guard Gold certification for schools, and so there's a lot of a lot that goes into all that. But when it comes to exterior grade products and moisture management, it's hard to find other elements that can really endure the properties needed in those environments. So it is something, just for everyone to know, we are constantly looking into trying to address, and I know our new global CEO is very focused on that. But we feel very confident in the health and the well-being of the products that we do provide the market currently.
Thank you.
Yeah.
Thank you, Francisca. Okay, John Novak.
Can you hear me?
Yes.
Yep.
Hi. Your product is very vapor open, right? So that's usually a great thing. But for a house, I'm in the Pacific Northwest climate zone, marine climate. So for a house, designing a house with no overhangs. So I'm concerned that the material, I'm not too familiar with acrylic. I do know like traditional plasters, like lime plasters, really hold moisture. So wouldn't that siding be more, if it's going to get wet day in and day out, wouldn't there be much more potential for vapor drive into the building assembly if the siding gets wet? It sounds like, yeah.
Go ahead. So that's an interesting question, and something that we addressed a lot as EIFS manufacturer. So we are with the EIFS acrylic finishes and that base coat material. We do have it is a barrier, but yes, it does have the ability to breathe in and out. It is not blocking it. There is the opportunity to have products that will have wind load resistant, wind-driven rain resistance by the coatings that are put on the exterior for that. So if we look at the stucco applications, that is even more of a mass type of a product. We're much thicker. We're 1/2 inch, 3/4 of an inch.
Yeah.
So it's holding a lot more moisture in a stucco application. So on that side, the EIFS product is not going to absorb that type of water. You do also have the ability to do, I've done it before on Jersey Shore, areas where both EIFS and stucco, EIFS manufacturers do have waterproofing base coats. That's the term that they use. And what it is just a slightly lower perm rating. Some of the products are around 2.5, 3 perm. So that is a concern for you. But what I would suggest, and I have it up here on the screen, is to reach out to us, reach out to our building science group, and we'll do some modeling for you and have a frank discussion with regard to that specific to your region.
So you will do
I would
thermal.
emphasize. Yeah.
You'll do thermal modeling for us with
yes.
Wow.
And we'll do hygrothermal modeling. So if you have any moisture related questions, particularly in that climate, we can address that. I think the big thing out there is moisture management, and it's really on the wall level, and with EIFS, and Rob, you can correct me if I'm wrong, but it's the capillary break that you need in the drainage plane that's going to be really critical there, because you don't want to compromise drying from the inside to the outside either in that region. And so it's really getting that strategy right. I mean, the nice thing is that the vapor drive, inward vapor drive, you're not going to get moist mineral wool, but if you had no drainage space, then the solar driven moisture can push right into the wall. And so having that drainage gap is really critical. And then obviously the permeance of the membrane that you'd have on the wall is something that I think, Rob, you were just mentioning needs to be under consideration. But fully, we're happy to run that modeling for you guys.
Yeah, that's what I would want to prove to me, because I think that would be.
Yep.
Yeah. And then are there options for a thicker drainage plane? I mean, you said it comes out to be 1/8 of an inch or so. Is there an option to have a little bit of a thicker drainage plane?
Not for the how should I phrase this? for non-combustible applications. So a combustible construction, excuse me, let me phrase it that way. For non-combustible construction, that's pretty much the requirements. That's the way that the materials are tested to NFPA 285. When you get to a combustible construction like Type 5, you can start to look at adding things that are combustible, like a three-dimensional drainage mat. So creating that behind it can give you that, change that thickness to it, but it's not. It would be only appropriate for non-combustible, or excuse me, combustible construction.
Yes. So the drainage mat you could put, but then you would have to increase your physical attachment points. At which point, you know, you'd have to have a lot more and then that sort of deteriorates the thermal performance, right?
Yeah.
So it's this balance. So I guess I was just thinking, you know, like a thicker trowel, you could just, to get a little bit of a thicker gap, because just an 1/8 inch just seems risky. Like I'd be happier with like a 10 millimeter or 8 millimeter gap. Right. And so I was like wondering if you could just use a really thick trowel.
Well, again, it would be the ribbons that you would be creating and compressing of those ribbons. When you compress those ribbons, you can't go any further. So one of the compromises that you would have there, if you're creating a thicker drainage plane, you would have to somehow stop pushing and squashing those, and then be consistent with it. This presentation, or these products are also available in Canada as well. And Canada does have some they do have an alternative in Canada where they take the boards and it's called GDDC, I believe. I thought I had a picture of it.
GDDC.
Yeah, and so that there's grooves actually being cut in the back of the board to help facilitate that drainage, and they're not actually adhering it with the ribbons. In the past, with foam eaves, we would have that, where grooves were cut in the back of the board and still adhesively adhered. Just kind of a belt and suspenders type of thing. But currently, the manufacturers aren't providing or looking at that currently.
Okay.
So interesting on the stucco application I was trying to show you here. This is a stucco application of a hotel in New Jersey, and this is the comfort board, and they did the vertical ribbons of adhesive to install that comfort board so that they didn't have any more additional fasteners for, say, like a drainage mat that was behind it. So just wanted to point that out.
But then they've also got that drainage mat. It looks like that black member, that's vapor impermeable.
So no, this is all permeable. This is just builder's paper, and then you've got your drainage mat, and then in this case, it was wire lath, and then 3-coat stucco over top of it with a crack shield over top of that, and the Santa Barbara mission finish on top.
Seems like it would hold a lot of moisture.
Well, that's the way. That's what stucco does. It is a mass type wall. It is going to hold that moisture, and in this case, the drainage, they had drainage both behind and in front.
Yeah.
Okay. Awesome.
Thank you.
Thanks. Great questions, John. Appreciate it. This has been amazing. We are nearly an hour and a half in. We have a couple of follow-up questions questions that I want to follow up on from a couple of people who had to leave early. If you, Rob, Todd, and Manaz still have time to another couple of minutes. Okay, sure. Great. So the first one comes from Graham Irwin, and he asks, is there an exterior lime plaster option that's available and approved in the US?
So if we're talking about a traditional 3-coat metal lath stucco application, we certainly, look at those manufacturers. For that, they'll provide that system, but the EIFS, installing something like that over EIFS is not usually recommended, just because of the flexibility of it. You want to have that that thickness of the plaster of the mortar bed application.
Got it. Okay, great. So Simone Goldfelder, this gets to the question of the penetrations through the WRB. So she asks, can you discuss the installation of the stone wall, multiple fastener locations, and WRB systems, i.e. a lot more penetrations / mechanical attachments through the WRB? So I think that's the concern.
So interesting question, and certainly something that is of concern, especially with building envelope people having the blind fasteners. Even if it's a stucco application or an EIFS application, yeah, if you've got to mark your board with where those stud placements are, and if you miss the studs, you've got to leave that fastener in there. So I'll talk about two different options, and one is the use of fire blocking and a foam EIFS system. In this case, I won't get into a whole lot of specifics, but so this is an application, there's absolutely no fastener. So it's an option. It's utilizing both foam and mineral wool. If you're okay with maybe using a little bit of foam and you want to have some fire blocking and have some insulation that way, that's certainly an option. One of the things that we're actively looking at Rockwool, because this question is coming up quite often, is the use of a product like that I have on the screen here, which is the Thermal Grip Tube Seal. So what this does is when the fastener goes through the insulation and the metal portion of that fastener punctures the WRB and then goes into that stud, as the fastener and the washer compress, the plastic shroud, it then seals that opening. All of the testing from EIFS manufacturers do test it to, can't remember the name right off the top of the bat, an ASTM test for nail sealability. And but that also is for screws as well. So as you penetrate through that WRB, the term they use is self gaskets around that. So yeah, so we do have the potential of missing that stud and having that opening, but again, it's a big part of that application. So also manufacturers that have six fastener pattern, obviously we're minimizing the amount of penetrations there as well.
I think that's ASTM D 1970.
You could
nail
be right.
sealability.
Yeah.
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 Perfect. Great. Thank you. Our last question is a great one. This is from Ann Williamson, and she asks, where is the stone origin material harvested?
So that is a closely guarded secret, so much so that I ask and I get the you don't need to worry about it because don't worry, it's local.
Okay.
It is a closely guarded secret, but we can pull up our there's a lead generation tool. There's some other things online, and I've had those asked and answered by saying we are sourcing it from local areas and close to the plant. So, and you can generate that lead letter, and you'll see that it's within the distance that's might be required for that lead requirement. So.
Yeah, generally speaking, if I may add, basalt is what we use predominantly in our product, and that can be found pretty much anywhere. So it's also not a challenge really for us to go local.
Great. Well, fantastic. What an awesome presentation and discussion here. We're getting lots of great comments in the chat as well. Thanks so much, Rob and Todd and Manaz for presenting. And again, a big thank you to Rockwool for Rockwool's support of Passive House Accelerator. Before we close up, do you have any closing thoughts you want to share with folks?
Again, as I have on the screen, please utilize Manaz, myself, Rob Blunt, Todd Kimmel, for all of your questions, concerns, specifications, needs. But the real support is behind the scenes from us with our Rockwool Building Science Group. And lastly, we do have a lot of guides, including an EIFS guide, to where it's a lot of great information at your fingertips. You can download these, and it has hyperlinks to all the good stuff like product data sheets and sustainability considerations.
And I'm just going to add, it's great that we've, it's been a long time coming trying to generate these types of systems, and we're thrilled to have it. And we're thrilled to have Rob as a resource for us internally. As you can tell, he's a wealth of knowledge and really can help support you guys in the transition to Stonewall EIFS. We have a lot of other solutions for other types of full building continuous installation options. So if you guys are not familiar with using, Rockwool below grade, foundation walls, under slab, lot line conditions, low slope roofs, we can offer a lot of guidance on that. So you guys have our contact information. We're happy to kind of walk through that kind of stuff for you moving forward. And for those of you who are doing business and working on projects in WUI zones, we're pretty excited that we're going to be launching some fire resiliency details, whole building, resiliency details, hardening details. So please stay tuned for that. If you don't see something coming out on social media from us soon, please ping us. It's not, the fire resistance is not just Rockwool. It's a whole package of things that you need to consider, from landscaping to eaves to, ventilation, et cetera. And so from what I've been told is these details cover soup to nuts. And that they've been, there's been a lot of collaboration with industry experts on generating that. So we're super thrilled and hope to have that information out soon. Closing thoughts. Those were mine. Thank you, everybody.
Timely.
Yeah.
All right. Fantastic. Thanks. Be well, everyone.